Hello, welcome. Today let's try to solve another lead code problem. 1438, longest continuous subarray with absolute diff less than or equal to limit. So this is the longest lead code title. But this problem is easy to understand. We first have a nums array, and we also have a limit. So let's check the limit. So limit is the maximum number and the absolute value of the two numbers inside a window. So for example, in the window 247, for example, in the window 247, the limit is 5 because 2 minus 7, absolute of 2 minus 7, it is 5. It is more than the limit. So the window has to be 47 or 2 and 4. So that is why the result is 2. Because for 8, it can just be one number. If 8 with 2, it will be more than the limit, because 8 minus 2 will be 6 and the limit is 4. So the maximum window will be 2. So let me first explain the problem in the whiteboard. After that, I will go to the code editor to finish the coding. So this is a sliding window problem. Basically, there are two ways to solve this problem. First, I'm going to use the sliding window directly to solve it. I'm going to use the sliding window. And second, I'm going to use a monotonic queue to solve the problem. So there are basically two methods. For the sliding window, it is n log n time. And for the monotonic queue, it's going to be O(n) time. Now let me first explain the sliding window method. Because inside a sliding window, basically what we want to find the maximum and smallest number. Let's use this example. So the first number is 10, 1, 2, 4, 7, and 2 inside the nums array, and the limit is just 5. So we're going to use the sliding window to find a solution of the maximum window. So what are we going to do? For this problem, we need to find the maximum number and the minimum number inside a sliding window. Basically it will be O(n) squared times complexity. But in Python, there is a library from the sorted containers. It is called sorted list. So inside the sorted list, we can find the smallest number or the biggest number. It will be ordered because, for example, inside the numbers, for example, there is 1, 2, and 10 for the first three numbers. Inside a sorted list, it will be sorted in order. And we can remove each of the numbers inside the sorted list. For example, if we want to remove a number 4, it will also take log n time. So this is why for the first problem for the sliding window, basically we are using sliding window, we cannot find the minimum and maximum number. We have to use the O(n) time to find. But for the sorted list from the Python sorted container library, we can remove or add a number just in log n time. That is why I'm going to use the sorted list. Let me explain the solution. So first of all, inside of the sorted list, I'm going to add the first number. So the L pointer, I'm going to prepare an L pointer for my sliding window left. And then I'm going to loop through from the I pointer for the first number to the last number. So the I pointer pointed to the 10 as well. So for the first number, I have a number 10. When my I pointer pointed to this 10, I'm going to put it inside the sorted list. So I'm going to have a number of 10. Then I'm going to use a while loop to check if it is out of the limit. So the limit is 5. So for the sorted list, from the left side, it is still 10. The right side is also 10. So 10 minus 10, it is 0. 0 is less than 5. So it means I don't need to remove any number from my sorted list. So here, the sorted list is my sliding window. So my result is just R minus L plus 1. So R is pointed to 0 and L also pointed to 0. So the result is 1 currently. And then for my R pointer, I will point to the next number 1. So I'm gonna put 1 inside my sorted list. So the sliding window have 1 and 10. It will be sorted in increasing order. Now, what I'm gonna do, I'm gonna use a while loop to check the sliding window if it is out of the limit. So I'm gonna use the SL minus 1, the largest number, minus SL0, the smallest number. It's gonna be 9. So 9 will be more than 5. It means it's outside of the limit. So what I'm gonna do, I'm gonna remove the number from the L pointer. So the L pointer pointed to 10. So I'm gonna remove this 10. After removing the 10, I'm gonna still use the while loop to check if it is okay. So after moving 10, what I left behind, it is just 1. So the SL minus 1 minus SL0, the maximum minus the smallest, it becomes 0. So 0 is less than 5, so it is okay. Now I'm gonna update my result. So my result is R pointer pointed to the index 1, L pointer pointed to index 0. Yeah, so 1 minus 0 plus 1. So my result will be updated to 2. Yeah, so after updating, yeah, but before updating the, let me check. So yeah, but the result will be updated to 2. But for the L pointer, it is not working inside the while loop. Yeah, but the result is not updated yet. Yeah, I'm sorry, I explained something wrong. Yeah, because the L pointer has already also been shifted to 1 because the 10 is not working. After I remove the 10 from sorted list, so my L pointer will be shifted from the 10 to the next place. So first it is at 0. Now it will be shifted to 1. So the L pointer pointed to index 1 and R pointer also at index 1. So the result will still be 1. So currently in my sorted list, I have a 1. Now my R pointer will go to the number 2. I'm gonna put 2 inside my sorted list. So I'm gonna check if it is okay. The limit is 5. It is okay. Now the R pointer will go to 4. I'm gonna put 4 inside. So 4 minus 1 is 3. 3 is less than 5. It is okay. Now my R pointer will go to 7. So I'm gonna put the 7 inside my sorted list. It's a sliding window. So 7 minus 1 it is 6. 6 is more than 5. So what I'm gonna do, I'm gonna remove the L pointer. L pointer pointed with number 1. So I'm gonna remove number 1. What I left behind, it is 2, 4, and 7. So I'm gonna still update my result. So my result would be updated to 3. Yeah, because as you can see, inside the sliding window, it has 3 numbers inside the sorted list, but L pointer already pointed to 2 and R pointer pointed to 7. So R minus L plus 1, it is 3. Now R pointer will go to the last number 2. If R pointer go to the last number 2, I'm gonna put 2 inside my sorted list. So after I put it inside the sorted list, it would be 2, 2, 4, and 7. Now I'm gonna check 7 minus 2, it is 5. 5 is less than and equal to 5, so it is still okay. So I don't need to shift the L pointer. I don't need to remove any number inside the sorted list. So I'm gonna still get my result should be R minus L plus 1. So the R will be pointed to 2 and L pointer is still at this 2. So the distance from 2 to 2, so it's gonna be 4. So this is the final result. It is 4. Yeah. Let me first code it up from the code editor for the first method of a sliding window. Basically, this is really easy to understand, and yeah, it really makes sense because inside my sorted list, basically, I'm gonna have a curve like this. It's gonna be always increasing. So if it is increasing, I can always find the minimum number and the maximum number. I can use those two numbers to check if it is inside the limit 5 or not. Yeah. If it is not working, I'm gonna remove some numbers from the L pointer. Maybe the L pointer first pointed to this number. I'm gonna remove it. It doesn't matter. Now maybe for the next one, the L pointer maybe pointed to the smallest number, I remove it. Maybe it gonna work. Yeah, because I never know the L pointer pointed to which number inside my sorted list. Because inside the sorted list, the number has already been sorted. But I can remove any number which is pointed by the L pointer. Yeah, which is pointed by the L pointer in log n time. This is why the time complexity is n log n, and we can solve it. Yeah. Now let me finish the coding for the first method. As I explained, I'm gonna use a sorted list. So from the sorted containers. So from the sorted containers, we're gonna use import this sorted list. The sorted list is basically a new library from the Python. I think it can use in Python 3.10, and after that, I'm not sure it is a 3.9, but in LeetCode you can use the sorted containers. You can, in LeetCode you have to import it. Because for other libraries it is imported automatically, but for this sorted containers, we have to import by ourselves. Now let me prepare the sorted list. So it's gonna be just the sorted list, and I'm gonna define an L pointer and result. So the L pointer will start as from 0, and the result is also 0. My final return will be the result. Yeah. Now let me just use the sliding window template to solve the problem. So for R in range, len of nums. Yeah, we're gonna put the first number inside the sorted list. So it should be add nums R. Now, after we put it inside the sorted list, we are going to check the sliding window. So while SL minus 1, the maximum number, minus SL 0, the minimum number, if it is more than the limit. Yeah, it means it is out of the window. What I need to do, I need to remove the current number from the sorted list. So I need to remove from the left side to the right side, because the sliding window is from the left to the right. So the SL dot remove with nums L. Yeah, because currently this number is pointed by nums L. After remove this number, L pointer should be plus 1. And if it is still more than the limit, I'm gonna still check for the next number pointed by L, and then L should plus 1. If everything is okay, I'm gonna update the result. So the result will be R minus L plus 1. Now let me run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases, and it's 43%, but it is not so fast because this is n log n time. Yeah. Now I'm going to use the monotonic queue method to solve the problem. But before that, I will first go to the whiteboard to explain my solution. After that, I will code it up from here. Yeah, why we can solve this problem by using the monotonic queue. Basically, if we are using a monotonic increasing queue or decreasing queue, we cannot solve it. Yeah, because this problem is let us to check the absolute diff. It means the maximum minus the minimum numbers, basically. Yeah, let me explain from here. Yeah. So for this problem, inside the numbers, it can be increasing or decreasing. Basically, it's a curve, some curve like this. Yeah. If we are going to use a monotonic queue to solve the problem, so for the first number, maybe we're going to use a monotonic increasing queue. It is like this. Yeah. But from some other places, it will be the curve will be decreased. It means we will always miss some numbers if we just use the monotonic increasing queue. Similarly, if we are using the monotonic decreasing queue, yeah, the curve may at some places it is decreasing. Yeah, but if you are using the monotonic decreasing queue, if the numbers, so for example, this may be like 3, 2, and 1. Yeah, inside of the monotonic decreasing queue, maybe you can put like 3, 2, 1, and our limit maybe, yeah, maybe the limit is 3. Yeah, but from here it will be increase. So what's gonna happen? It's gonna be have like 2, 3, and 4. Yeah, yeah, it will increase. So from here it is like 3 to 1. Now you have a 2 because you wanted to keep it decreasing. Yeah, so it's gonna be a 1 will take it out. It's gonna be 3, 2, and 2. And then you're gonna have a 3. You're gonna take this 2 out. Now you have a 3 and 3. And when you have a 4, you're gonna take it out, and you're gonna use a number 4. Yeah, maybe you have a bigger number. Maybe it is a 7. You're gonna use the 7. Yeah, so it means from the left side you always have the maximum number. But if you are using the monotonic decreasing queue, you're gonna always miss some numbers while checking, because for this yeah, because it is decreasing 3 to 1, you're gonna check it is inside the limit. But while the number increased, you always pop the numbers out, and yeah, basically you didn't check every possible solutions. Yeah, let me explain the monotonic increasing queue and the decreasing queue method. So basically, for the monotonic increasing and decreasing queue, no matter what the curve is, it is like a two pointers method. First of all, we're gonna have a decreasing curve for the monotonic decreasing queue, and then we're gonna have a increasing curve for the monotonic increasing queue. And from the head of the queue, there are 2 points. And these numbers, if this is the maximum, because this is monotonic decreasing queue, yeah. And if this is the max, and this is the minimum numbers, if the max minus minimum, it will always be the maximum difference of the numbers inside the window. Because for example, this is 7 and this is 1. 7 minus 1, 6 will always be the maximum diff. Because here, gonna be always smaller. And here will always be bigger. Yeah, but actually for the monotonic queue inside, it cannot go to these areas. Yeah, let me give you an example. It can only go to these areas. This is why we're gonna use the max minus the minimum from the head of the queue. Let me give an example, like 7, maybe 5, 7, 5, 6, 4, and 3, and the limit L is only 3. Yeah. So for the monotonic decreasing queue inside, for the first number, I'm gonna put a 7 inside, and for the monotonic increasing queue, it is similar. I'm gonna put a 7 because it's the first number. So the head of the queue for the monotonic, is this gonna be? Yeah, let me put it. This gonna be increasing, and this gonna be decreasing. Yeah, for the increasing decreasing, for the first number, it's the same. So 7 minus 7, it is 0. 0 is less than 3, so it's gonna be okay. So my sliding window currently result, this is my result, is 1. Now I'm gonna put 5 inside because it is monotonic increasing queue. So I'm gonna take 7 out and put 5 here. Yeah, And it is a monotonic decreasing queue for the second. I can put the 5 inside the monotonic decreasing queue. Yeah. Now I'm gonna check 7 with 5. Because for the monotonic decreasing queue, 7 will always be the maximum. Minus 5, it is a 3. It is a 2. 2 is less than 3. It means it's a possible result, so it is okay. So the sliding window currently, I'm gonna update it to 2. Yeah, because this 7 pointed to 0 and this 5 pointed to the index of 5 is 1. So 1 minus 0 plus 1, it is 2. So it is okay. Now I'm gonna put the next number inside. So 6 will be here because it's monotonic increasing. And here I need to take 5 out and put 6 inside. Yeah. And then you can see like this. So here is 7, 6. Yeah, it is decreasing 7 and 6. And here is yeah, the decreasing is 7 and 6. This is 7. Increasing is 5 and 6. You can see it is like this. Yeah. So we are sure 7 minus 5, it always be the maximum possible result. So it is 2. It is okay. Yeah. So currently, what's the result? So the currently result should be updated to 3 because R pointer has already go to 6 and the L pointer is still pointed to 7. Now we are going to put the next number inside. For example, we're going to put the 4, so the R pointer will go to 4. So for the increasing queue, I'm gonna just take the 6 and 5 out because it's increasing and put a 4 here. For the decreasing queue, I'm gonna put the 4 inside because it is a decreasing 7, 6, and 4. Now I'm going to check the head of increasing and decreasing. It's 4 and 7. As you can see, 4 is here. So it means for the decreasing queue, it is 7, 6, and 4. Yeah, this is 7, 6, and 4. For the monotonic increasing queue, it is only 4. It is at this point. Yeah, you can see that it is always the maximum result by using 7 minus 4. Yeah, it is 3. So it is inside my limit. So I'm gonna update my result to 4. Yeah, because 7 to 4, it is still okay. Yeah, you can see the curve will always be like this, or like this, or the curve will be like this. So this is why we can solve it easily by using the monotonic queue. There are only 3 possible curves. It's these curves. There's never a curve like this. Yeah. Now let's try to put the 3 inside. Now let's put the 3 inside because it is increasing. Yeah, but here it is decreasing. We're gonna take the 4 out and put the 3 inside the array. Yeah, and here we're gonna take the 3 inside. Yeah, put the 3 inside the monotonic decreasing queue. Now we are going to check 3 and 7. Yeah, if it is 7 and 3, for example, here is 3. It means 7 minus 3, it is 4. 4 is more than the limit of 3. What we're gonna do, we're gonna check the sliding window. Currently, the L pointer pointed to 7. What we're gonna do, we're gonna check if this 7 is inside the front of my increasing queue or decreasing queue. Inside the increasing queue, there's no 7. It is okay. But inside the decreasing queue, the first number is 7. What are we gonna do? We're gonna pop the 7 out. Yeah, if we pop it out, what is left behind? So the L pointer will be shifted to 5. Yeah, because I popped out the 7. So what's left behind? This is L pointer and this is R pointer. Yeah, let's check if it is safe. So after pop it out, so my maximum number currently for the decreasing queue, it is 6. And for the monotonic increasing queue, it is 3. 6 minus 3, it is still 3. So 3 is less than or equal to the limit 3, so it is okay. So my current result is still 4. And I've already looped all the numbers. And this is the result. Yeah, actually it is really difficult to understand. I spent a few days to understand this monotonic increasing and decreasing Q problem. And then I find, because I find the curve, it is like just like this. Monotonic increasing and decreasing, it is like this, or it is like just increasing, or it is just decreasing. This is why we can solve it by using the monotonic increasing and decreasing Q together to solve the problem. Now let me go to the code editor to finish the coding. I think it already spent quite a long time, so I will just speed up a little bit of the coding. Because for the coding, basically it's a template. Everything would be the same. I'm gonna prepare the L pointer and result. So I'm gonna prepare a monotonic increasing Q and monotonic decreasing Q. So the L pointer will still be the 0 from the left side, and the result is also 0. I cannot type. And the monotonic Q is dq, and I cannot move my fingers so quickly. It says stiffen. I got a stiff finger. Monotonic freezing. I got a freezing finger. I cannot type. So I have the left pointer and result, and then I'm gonna prepare a monotonic increasing and decreasing Q, and then I'm gonna use the for loop. It's similar like before. So for I in range line of nums. Now I'm gonna first prepare the monotonic decreasing Q. So while monotonic decreasing Q exists and monotonic decreasing Q for the last number inside of the Q, if it is more than my current number, nums R, so here gonna be the pointer R. Now let me check if it is right. So for example, monotonic decreasing Q, it is the number 10, and my current number is 9. 10 is more than 9. I'm gonna pop. 10. Basically while writing this, I'm gonna just imagine inside of the monotonic Q, decreasing Q, I'm gonna have a number 10. My current number is 9. If it is like this, I'm gonna pop it out. But basically for the decreasing Q, I don't need to pop it out. So it means more than should be less than. It is not right. So if the numbers like 10 and 11, I'm gonna pop 10 out and put 11 inside, because this is the monotonic decreasing Q. So monotonic decreasing Q should pop from the right side, and then I'm gonna put it inside, put my current numbers inside the monotonic decreasing Q, so it should be nums R. Similarly, I'm gonna copy this lines of code to prepare the monotonic increasing Q. So for the monotonic increasing Q, I just need to change the decrease to increase. Basically, it's the same. And here, I'm gonna use a more than. And here, I'm gonna change it to monotonic increasing Q. And here will still be the increasing Q. Finally, I'm gonna return the result. But before return the result, I'm gonna update the result. It should be R minus L plus 1. But in between, I'm gonna prepare the sliding window check to check if it is outside of the limit. So actually, the check is not so difficult. So while monotonic decreasing Q 0, it should be the maximum number, minus the monotonic increasing Q 0 is gonna be the smallest number. If it is more than the limit, it means I need to do some check. So I'm gonna check these numbers. If nums L pointed to L, this number, I'm gonna check if this number equal to the monotonic decreasing Q or monotonic increasing Q. If it is equal to the monotonic decreasing Q, what I'm gonna do, I just need to take the pop the number out from the monotonic decreasing queue. So monotonic decreasing queue should pop from the left side. Yeah, and another check is, let me just copy it. Yeah, just to avoid making some typo mistakes. So if nums L equal to the monotonic increasing Q from the head, from the left side, I'm gonna, pop from the left side. Now, after that, I'm gonna check the result. Yeah, basically this is the entire code. From here, I maintained two queues. One is monotonic decreasing, one is monotonic increasing. And from here, I'm gonna check the sliding window part. If it is more than the limit, I'm gonna do something to check the nums L from the left side. If it is equal to the monotonic decreasing Q from the left side, the first element, I'm gonna pop it out. If it is equal to the monotonic increasing Q from the left side, I'm gonna still pop it out. And this is the final result. Now let me run it to check if it works. Max should be result with R minus L plus 1. Here, I think I did something wrong. From here, I didn't update the L pointer. So after each of the operation, I need to update the L pointer to 1 because I need to check the next number. So the sliding window needed to move from 1 to another number. Yeah, now let me run it to check if it works. Yeah, it seems to work. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases and it's pretty fast. It becomes 0.2 seconds. From beginning, if you remember, it is 1 second. Yeah, it is 96% of all submissions. Thank you for